Okay, so now we're going to solve for a parallel circuit. So what we do, same thing as before, we're always finding our totals, and then we're always finding our totals first. So the first thing I'm going to do is add up my voltage. 3 and 3 makes us 6 volts. And then we're going to find our resistors. Now, on a parallel circuit, the trick with resistors is that it's the inverse. So you use the inverse. So instead of being 6 plus 3, it's 1 over 6 plus 1 over 3. And there's a button on your calculator that makes this very, very easy. And this would equal 1 over our answer. There's a button. It is the third button underneath the second function key, and it looks like this. It is x to the minus 1. Now, you don't need the second function key. You don't need to press the second function key. That's just location-wise. So the button looks like this, and what we do is we hit 6 and then hit the inverse key, and it's going to look like this, to the minus 1, plus 3, hit the inverse key, and it'll look like the minus 1. You hit equals, and it gives you an answer. Now you need to take that answer and hit inverse one more time. So now it says answer, because this should say 0.5, answer to the minus 1 equals, and we should get 2. That is our total resistance for this circuit. And this makes sense. 2 is a smaller number than 3. By having multiple pathways for the currents to flow down, there's less resistance overall. So if electrons are getting stuck going through the 6 ohm resistor, they could just move on to the 3 ohm resistor. So overall, on a parallel circuit, your resistance should be less than the smallest resistor on your circuit. Okay, that's why we have parallel circuits, because it makes and allows the electrons to move faster. Now again, to solve for current, it's just V equals I times R. So we put in our numbers, and we've got 6 equals I times 2. So this becomes 6 divided by 2. So our current is 3 amps. Now, that's our total current. On a parallel circuit, each wire pathway can have a different amp than the other one because there's multiple pathways that the electrons can flow, so there's multiple currents. Okay, so to solve our resistance grid, we're going to again put in for each resistor, so we've got 6 and 3. Now I just told you that each resistor and each wire pathway can have a different current. So what stays the same and what's constant on a parallel circuit is the voltage. So these will be 6, just like our voltage total up here at the top. Again, to solve for this, V equals I times R. So this is going to become, we're looking for our current, our I. So this becomes 6 divided by 6, which is 1, and 6 divided by 3, which is 2. Now, just to check and make sure, 1 plus 2 equals 3 amps, and if that's what I have as my total, then I did this correctly.